You, along with probably like 97% of enterprise leaders listening right now, have definitely experimented with generative AI.
Oh, absolutely. Everyone's run the proofs of concept by now.
Right. You've seen the parlor tricks, you've played with the models,
Mm.
but how many of you actually have it running autonomously in production?
Like completely unattended.
Exactly.
Yeah.
Executing critical workflows while you sleep.
Yeah.
Because if we look at the reality inside most European enterprises today, that number drops to, practically zero.
Yeah, it's virtually non-existent.
So today we are doing a deep dive into that exact disconnect. We're unpacking a really comprehensive blueprint from AetherLink to figure out how to take these flashy prototypes and actually weave them into multi-agent systems that scale.
And critically, do it without running afoul of the new European regulations.
Right, because the stakes are high.
The urgency here really cannot be overstated for the business leaders tuning in.
Yeah.
We're totally past the theoretical phase now. According to IDC, European adoption of multi-agent systems grew 156% year over year in 2024.
Wow, 156%.
Yeah, the infrastructure has matured. We have this massive pool of homegrown talent, like from Mistral AI, and the market momentum is just forcing everyone's hand. I mean, Gartner is showing a 43% faster task completion rate.
That's massive.
Right. And a 38% cost reduction in repetitive processes when you deploy agentic workflows. So the financial incentive is it's huge.
But, and this is the crazy part, we're watching those same organizations hit an absolute brick wall.
Yep, every time.
They try to capture those efficiency gains, and suddenly they collide with the 2025 and 2026 EU AI Act enforcement phase.
It's total enterprise paralysis.
Exactly. You have this incredibly powerful engine, but you're terrified to take it out of the garage because, a compliance penalty could end the company.
Right. But before we even untangle the legal piece, we have to baseline the architecture, because a lot of people conflate the 2023 chatbot with the 2026 AI agent.
And they are fundamentally different things, right?
Worlds apart. Conflating them is exactly why so many deployment strategies fail. I mean, a traditional chatbot is stateless and reactive.
Like a smart dictionary.
Exactly. You ask a question, it predicts the next word, gives you an answer, and its job is done. But an AI agent is stateful. It's goal-oriented.
So it's more like hiring an intern.
Perfect analogy.
Yeah.
You give it an objective, say, optimize inventory for the Q3 push, and the agent enters this autonomous reasoning loop.
It's actually doing the work.
Right. It breaks the goal into subtasks, it makes API calls, pulls data from the ERP, and just iterates on its own logic until the job is finished.
And that shift from just, reacting to actually doing completely flips the ROI calculation.
Absolutely. It's why Forrester's projection says agentic AI will drive 61% of enterprise automation investments in Western Europe by 2026.
Because you aren't just speeding up one task anymore, you're collapsing whole multi-step, cross-departmental decisions into like a single computational process. But I have to say, this is exactly where my alarm bells start ringing from an architecture standpoint.
Oh, the security aspect.
Yeah. One agent is a manageable risk. But if I'm deploying a procurement agent, a finance agent, a logistics agent, and they're all operating independently, who is directing traffic?
That is the million-dollar question.
Letting autonomous entities just execute commands across core databases sounds like an absolute nightmare.
Well, it is a nightmare if you rely on the model itself to self-govern. You can't just unleash them. You have to build the roads and the traffic lights first.
So what does that look like in practice?
It requires deterministic infrastructure. You need conflict resolution, like what happens if the forecast agent says buy, but the finance agent says freeze spending?
Right. There has to be a hierarchy.
Exactly. And you need immutable audit trails.
Mm-hmm.
But mostly you need a way to connect these language models to your systems without giving them raw database access.
Okay.
And that's where the Model Context Protocol, or MCP, comes in. It's the foundational layer.
I've actually seen AetherLink's development arm, AetherDV, lean heavily into MCP for their Eindhoven implementations. Let's break this down, because a lot of people still think about access like human user permissions.
Right, which doesn't work for AI.
Yeah, if you give an LLM an API key, the attack surface is huge. It could theoretically string together commands you never intended. So how does MCP physically restrict the model?
So MCP servers act as these stateless, highly restricted API gateways. The model never gets direct access to your database.
It's like a highly restricted corporate keycard.
Exactly. The server only exposes very specific pre-approved functions to the model, formatted as strict JSON schemas.
Okay, so give me an example.
Say your supply chain agent needs to check warehouse stock. The MCP server provides a check inventory endpoint. The LLM can only interact with that specific schema.
Oh, so it physically lacks the pathway to, say, write a random SQL command and mess with the payroll system.
Right. It couldn't drop a database table, even if it hallucinated and wanted to. It's compartmentalization at the protocol level.
The agent doesn't even know the HR database exists because the MCP server just doesn't put that tool in its context window.
Exactly. And that provides the isolation you need. Plus, every single time the agent calls a tool, the server logs the interaction, the context, the payload.
Which is huge for compliance later. Perfect observability.
Yep. But there is still a vulnerability here.
Even with the sandbox.
Yeah. You can lock down the access, sure. But if the agent pulls the right lever based on outdated information, it still causes damage.
Oh, right. A perfectly sandboxed agent operating on a stale training set.
Exactly.
So if it thinks the 2023 refund policy is still active, it's going to flawlessly and securely issue the wrong refund.
Precisely. Securing the perimeter doesn't fix internal data validity. We have to force these models to operate on today's reality.
Which brings us to Retrieval Augmented Generation, or RE.
Right. RE grounds the reasoning engine in your verified enterprise truth. Instead of relying on the data the model was trained on, it forces the agent to retrieve relevant documents from your vector database first.
And the AetherLink blueprint had a great example of this. A logistics firm in Eindhoven used ARG for their customer service agents.
The results there were incredible.
Yeah, by anchoring the agent in real-time shipping records, their first response accuracy jumped from 67% to 94%.
And pushed their net promoter score up by 18 points.
Which is a massive operational win. But, implementing enterprise RAG is way more complex than just plugging a database into an LLM.
Oh, for sure. The failure modes just shift.
Right. Instead of the model hallucinating, the retrieval system just fetches the wrong document. Like if it pulls a draft contract instead of the final PDF, the agent confidently generates a useless response.
Which is why you have to measure it. AetherLink's consultancy practice focuses heavily on specific evaluation pipelines for ARG.
How do they measure it?
3 distinct vectors. First, retrieval precision is it fetching the correct context. You need benchmarks ensuring that stays above 85%.
Okay, what's the second?
Answer relevance. Did the LLM actually use the document, or did it ignore it and fall back on its own training data?
Oh, that helps a lot.
Yeah. And third is factual consistency. Does the final output contradict the source material? You have to automate tests for all these metrics before you ever hit production.
Okay, so we've got the architecture mapped. We're using MCP to sandbox everything.
Yeah.
And RA evaluation to guarantee accuracy.
Yep.
But we have to talk about the elephant in the room. In 2026, Europe, building a sandbox system is only half the battle.
Surviving the legal landscape is the other half.
Exactly. The EU AI Act classifies a lot of these autonomous systems as high risk. And I hear this from CTOs constantly. This heavy regulation is just stifling European innovation.
Well, the Capgemini data from 2025 actually shows 73% of enterprises view compliance as their primary barrier to adoption.
73%, that's huge.
It is. But the anxiety is only justified if you view compliance as a final stage checklist.
What do you mean?
If you build the system and then bring the lawyers in right before deployment to satisfy regulators, you're going to fail. The delays will kill you. But organizations using an AI-lead architecture approach are finding that compliance by design is actually a massive competitive advantage.
Wait, hold on. I need you to justify that. Because looking at the core mandates, Article 27 needs massive risk assessments, Article 13 is training data governance, Article 52 is transparency, Article 26 is human oversight.
Yeah, it sounds like a lot of red tape.
It sounds like endless NIST templates. You're telling me that forcing developers to build explainability logs actually speeds up time to production? That kind of defies basic logic.
It sounds counterintuitive, but it accelerates the cycle because it eliminates the rework loop.
Okay.
When you embed governance at the architectural level, the system generates its own compliance artifacts automatically.
Like as a byproduct.
Exactly. Take Article 13 on explainability. If you build with the MCP framework, every single tool call, retrieved context, and reasoning step is automatically logged by the server.
Oh, I see.
So when auditors show up, you don't have to retroactively reverse engineer a black box. The deterministic trace is literally just sitting in your database.
The architecture inherently satisfies the regulation. The logging isn't an extra step.
Right. And that solves Article 26, the human oversight mandate, which usually causes total panic.
Because leaders assume a human has to approve every single AI action, which completely ruins the whole point of automation.
Exactly. But compliance by design solves this programmatically. You use the orchestration layer to route decisions based on confidence scores.
How does that look in practice?
Say a finance agent processes a €5,000 invoice that perfectly matches the purchase order. The system executes it autonomously.
Makes sense.
But if it's a €50,000 strategic purchase, or if the RH confidence score drops below 90%, the orchestration layer intersects it.
And routes it to a human.
Yep. It compiles a summary and the reasoning trace and sends it to a manager for a single-click approval. The human is only in the loop where their judgment is legally required.
Wow. Okay, so we've secured it technically and legally, but the bill is going to come due eventually.
Oh, the compute costs.
Yeah. Running massive 70 billion parameter behemoths for every single autonomous thought, every interagent chat. That token burn rate will bankrupt an IT department in weeks.
The CFO will pull the plug instantly.
Right. So how do we mathematically make this scalable?
Cost optimization is the defining challenge right now. Forrester outlined 3 critical levers, starting with model selection, right-sizing the intelligence.
Because sending every prompt to a massive flagship model is financial suicide.
Exactly. You're paying a huge premium for reasoning capabilities you aren't even using. You need to deploy smaller, highly quantized models like 7 to 13 billion parameters for routine stuff.
Like formatting JSON data?
Yeah, or basic text extraction. Save the massive models for complex multi-step reasoning. That routing alone saves 40 to 60%.
Because it makes zero sense to use a supercomputer to categorize an email.
Exactly. The second lever is caching, and not just basic web caching, but semantic caching.
How is that different?
Semantic caching stores the vector embeddings of previous user intents. So if an agent calculates a supply chain variance, and an hour later, another agent needs the same calculation.
The cache mathematically recognizes the intent is identical.
Yep. It intercepts the request and serves the cached response instantly. You skip the LLM inference entirely, which saves another 25 to 35%.
Which compounds so fast when agents are talking to each other thousands of times a minute.
It really does. And the third lever is agent specialization.
Right, moving away from the God model.
Exactly. Instead of one massive prompt trying to juggle HR, marketing, and logistics, you narrow the scope. A specialized agent has a constrained prompt, so it requires way fewer tokens to process its context.
It's not cluttered with irrelevant knowledge. Processing is cheaper and faster.
And bringing it back to real metrics, the AetherLink blueprint detailed a financial services firm in Eindhoven that applied these 3 levers.
Right.
They dropped their per-transaction AI cost from 47 cents down to just 12 cents.
That's a 74% reduction. When you apply that across millions of transactions, you completely alter the company's margin profile.
It goes from an R&D expense to a core driver of profitability.
So let's put all of this together. The MCP sandboxing, the RG accuracy, the compliance routing, the cost optimization.
A real-world case study.
Yeah. The mid-sized manufacturing company in Eindhoven, they were dealing with absolute operational chaos.
It was incredibly fragile, wildly inconsistent supplier lead times, inventory forecasting running on disconnected spreadsheets.
And the finance team burning 40 hours a week just manually reconciling purchase orders. The interdepartmental friction was massive.
So Ethermine and AetherDivi architected a custom 3-agent orchestration system for them: procurement, forecast, and finance agents.
Let's look at how they interact. The procurement agent sits on an MCP server connected to the ERP, monitoring inventory and generating purchase orders.
But because of the MCP schemas, it's constrained. It can only use predefined vendor IDs and can't exceed budget limits.
Right. But it needs predictive context, which comes from the forecast agent.
Exactly. The forecast agent ingests historical sales, market trends, seasonal variations, and passes structured JSON models directly to the procurement agent.
They aren't just chatting in English, it's dense programmatic context.
Seamlessly.
Uh-huh.
And once the order is initiated, the finance agent steps in. It validates against the budget and uses a RAG to mathematically match incoming invoices to the original orders, line by line.
And tying it back to the EU AI Act, they built guardrails right into the orchestration. Any purchase order over 100,000 euros automatically triggered a suspension.
The system generated an explainability trace detailing exactly why the forecast agent recommended it and why the vendor was selected, and routed it to a human director.
The performance metrics on this are just staggering. Procurement cycle time was slashed from 5 days to 12 hours.
A 96% improvement.
And carrying costs for inventory dropped 22% because the semantic analysis was just so much better than their old spreadsheets.
And on the finance side, invoice matching accuracy hit 99.2%.
Which let the human team reclaim 38 hours a week to focus on actual strategy.
But from a governance perspective, the best metric was 100% audit trail completeness. 18 months in production, 0 EU AI Acts violations.
They built a legally bulletproof system that transformed their margins. Which brings up the big strategy question for CTOs. Do you buy an off-the-shelf solution or build this custom?
It really comes down to control versus speed. Vendor platforms are fast, but for European enterprises dealing with GDPR and legacy systems, that abstraction is a huge liability.
You lose control over data residency and model weights.
Right. Custom development using frameworks like MCP gives you ultimate control over your data sovereignty.
It's a heavier lift up front, but it creates a proprietary asset. So as we wrap up all this information, what is your single most important takeaway for the leaders listening?
My number one takeaway is changing how we view regulatory friction. The EU AI Act isn't a handbrake. It's a blueprint for robust engineering. By embracing things like MCP and AG, compliance becomes an automated byproduct.
It's an engine, not a barrier.
Exactly. You can scale aggressively while competitors are paralyzed by risk.
I love that. My takeaway centers on the economics. The monolithic AI approach is dead. The secret to scaling without destroying your budget is severe specialization.
Yep.
Architecting a network of narrowly scoped, highly quantized models is infinitely more efficient than relying on one massive general model. You don't need a supercomputer to do an intern's job.
You need a coordinated team of digital interns. And actually, I'll leave you with one final, slightly provocative thought about the future here.
Okay, let's hear it.
Right now, we're putting guardrails on internal systems. Our procurement agent talks securely to our finance agent. But think about 2027.
Oh, externalization.
Exactly. What happens when your perfectly compliant procurement agent needs to negotiate pricing directly with your vendor's AI agent?
Wow.
How do you maintain deterministic compliance when interacting with an opaque external intelligence? How do you audit a machine-to-machine negotiation executing thousands of variables in milliseconds?
That is the wild frontier of B2B commerce right there.
Right.
We fix internal orchestration only to plug into a global agentic supply chain.
It's going to be fascinating.
It really is. The gap between experimenting with AI and actual production is vast, but as this blueprint shows, bridging it just requires deterministic architecture and smart governance. For more AI insights, visit AetherLink.ai.